Welcome to another JS drop from ThisDot. In this drop, Ben Lesh introduces the concept of synchronous firehose, particularly relevant for those building their own flattening operators in RxJS. Ben delves into the process of building switchMap or concatMap operators and highlights the shortcomings of the conventional approaches. Finally, he provides insights on updates in the next version of RxJS. Like and subscribe for more JavaScript content. Let's get started.
Hey everyone, welcome today. Today we have Ben Lesh doing advanced RxJS with us. So there's a lot of expectations, Ben.
Oh no.
A lot of expectations happening. But do you want to give us an idea of like what you're going to talk about? Like what is advanced RxJS?
Well, I'm going to specifically spend a lot of time talking about a situation called a synchronous firehose, which is, it happens and it's problem for people who build their own flattening operators in RxJS. So this should be as advanced as anyone gets with it, to be honest, in my opinion. But yeah, so effectively, I'm going to build like a switchMap or a concatMap, and then I'm going to show you why the naive way that we tell people to build things is a little broken. And I'm going to talk about how to fix it. And then I'm going to talk about what's coming up in the next version of RxJS that will make it better.
So excited. Comments and questions welcome. All right. We're ready for the fire hose.
All righty. Hey, look, I see Dario. Hi, Dario. All right. So let me share my screen again. Stackblitz. Everybody knows about and loves Stackblitz, right? Because it's awesome. All right, so Stackblitz is cool because we've got this RxJS thing that they let me have that's like in their popular, I don't know how popular it is, but I use it all the time. If you ever come here, I set this up a long time ago. It's got like examples you can kind of copy and paste in here. Like this, the best one is probably the animated dot trail. So you can literally just copy this and paste it here, and you get animated dots. Isn't that great? I mean, that's probably the most important thing that you've done all day.
I mean, if it was rainbow colored, it'd be better.
Right? Well, we can maybe we'll do that at the end. We have extra time. All right. So we already have RxJS and stuff. For the like this is still going. For the unindoctrinated, when I talk about a flattening operation, what I mean is you can actually get this with, like, nowadays you can get this with an actual array. So you can be like, okay, so I have an array and I have an array that has other things in it, right? And you can, if I console log array flat, oh, it doesn't like that because my TypeScript doesn't realize that that's a thing. Oh, sad. Well, we'll fix that later. But you can see that it flattened the array, right? And like this is flattening. So what you're doing is you're saying, if I have an array of arrays, P, I want to flatten it to an array of T. Now there's deep flattening, there's other stuff, but generally speaking, when you're talking about flattening, this is what you have. So if you had and this isn't even possible, but if you had a promise of promises, right? That's not a thing because it auto flattens. Or if you had an iterable iterables, same thing. You would just flattening would go this direction, iterable of T. So what I'm talking about is an observable, which is another set of things of observables. We flatten that to an observable. It's not of R, T there. It's not magic. It's not going to flatten to a different type entirely. But this would be what flattening is, right? So an observable of observables. And the reason this gets mind-bending is observables are basically functions or lazy sets, right? So if you subscribe to an observable of observables, and you never subscribe to any of the observables it's giving you, like, you're not really doing anything. You're just being like, oh, you're giving me functions. I got a stream of functions that I'm not calling.
Can we increase the font size?
Yep. Better?
What do y'all think? Maybe a little bit more, one more.
All right.
I'm blind.
Just look at the dots, Tracy. Look at the dots.
The dots are pretty.
All
It's
right.
like a GeoCities, like GeoCities
Yeah,
all
yeah.
over again.
It's
You should like rewrite a GeoCities website with RxJS, just so I can see things following me.
I should. There's a web. I'm not going to go to it here because I don't know what technically what's on it, but there's a website called Pinball Perfection for this place in Pittsburgh, Pennsylvania. That's a lot of P's. That their whole site is like a big Angel Fire GeoCities type thing. It's nuts. You should check it out.
Okay, but what would be more exciting if these little dots were like little pictures of your face? Like that would be so cool.
You're obsessed. Yeah, I mean, we can maybe play with something later. For now, we're going to talk about flattening operators, if that's cool. So if I wanted to flatten observable of observables, I could start off by just saying, okay, let's import of, so we can make observable of observable from RxJS. RxJS there. And then we can say of one, of two, and so on, right? This is an observable of observables. If I call this my source, and I look at this, it's an observable of number, right? So if I want to flatten this, well, if I just subscribe to it, just to illustrate this, if I just subscribe to this and log it out, it's going to be like, I get a bunch of objects, right? Not terribly exciting. Really, I would have to subscribe to each one of these internally. The reason that kind of sucks is if I was like, okay, so get these inner observables, and I would then inner subscribe to each one of these in console log. That's going to work. I mean, I'm going to see the values, and conveniently, this is all synchronous, right? So because these are synchronous observables that were given us, but if they were observables over time, which is what you need to account for, they tick out kind of randomly. It's weird. And the other thing is I can't unsubscribe from any of these. Like if this is like a long-lived thing, say maybe this is an observable of intervals or something like that, and I capture this subscription and I unsubscribe from it somewhere below, I'm still not capturing these. These could keep going, right? So there's some trickery inside of when you want to flatten observables, that because of the nature that they're lazy, you have to track subscriptions and stuff. So we have operators for this, and the operators that exist inside of RxJS for this are merge-map, which is just like, hey, subscribe to all the inner observables and like flatten out, merge all of their values together into a single stream. There is concatMap, which is like, all right, just do one, like for every one of these things you get, just do one at a time and wait till it's done and then subscribe to the next one. And there's, well, this is merge all, concat all in these cases, but they're the same: merge, concat, and switch under the hood. So switch is a little different. It still only does one at a time, but when you get a new one, it unsubscribes from the previous one it has and subscribes to the new one. So so this one's lossless, this one's lossless, this one is lossy, and then we have one more called exhaust map. And exhaust, the strategy is, hey, you gave me one, I'm going to ignore everything else until that one is done. And once that one's done, then I'll allow another one to start. So that one's lossy as well. So conceptually, these things are here, lossless, and then over here would be lossy, right? So just to put that out there, like these ones you're not going to lose any values. This one ensures order. This one keeps the order, but you could lose values. This one you could lose values. Order sort of maintained, but not really. Well, this one's the only one that doesn't maintain order because it will allow them to interleave as they're arriving. But all right. So these are all our strategies. If I was to use one of those, it just looks like this: pipe, and we'll do merge map. And I'll just flatten it out. So this is no longer an observable. This is the actual number. So we don't need to do this anymore. All right, so now we're flattening those out. So cool. This is a flattening operation. What I want to do is I want to show you how to build a flattening operation from scratch. And why would you do this? If you already have these other 4 strategies, why would you? And the reason that you might do this is there's other weird, obtuse things that you might want to do with observables. Maybe you want to arbitrarily merge things, or maybe you want to double something from some merge, or maybe you want to do something slightly more efficient internally that involves subscribing to some other streams. Those are all going to be technically flattening operations. But really the issue is having an operator that also subscribes to some other observable inside. And I'm going to show you why what I call a synchronous firehose works out bad with this. All right. So let's build our own merge map. So I'm going to nuke all this stuff. For now, I'm actually going to use like, let's make this observable slightly more fun. Let's just do interval and then make it tick every so often, and then type that to take, and let's just take, yeah, we'll do 5 values, sounds fine. So that, and then we don't have anything to merge map in there. So here, I just want this source to be a little bit more interesting. Here, we're going to end up like mapping it to something else, or I don't know. Anyways, let's, so there's our source. If we want to see what that source is doing right now, we can see it just outputs some numbers. And I'm just going to use this so we can map it into an inner observable or something and flatten that out with our custom merge map. Let's go down here and we'll say function my merge map, and it takes in a value and it's going to output a value type. And we have some mapping functions, so we'll call that our projection, or just project. It's going to take a value and it's going to project it to, we'll just say it's an observable of out, value in observable out. Import that. All right, so here's the basic shape of our operator. And what it's going to return is, I don't think it's funny that's still going. All right, what it's going to return is this shape that looks like this. This is an operator function. I'm going to write it out manually for now. Takes a source observable in, returns an observable of out. So that's the shape it's going to return. Now we have this thing called operator function that's a type that does exactly this. So this here, so I'm saying we're going to return source new observable. So this is basically where we're going to start with our operator. This here is the same thing as saying operator function in out. And here we've got a subscriber inside of this because we're creating a new observable. I don't know how many people here have done this before, but presumably you have. And what we want to do inside of here is we want to subscribe to this source. So we're going to say, take our subscription. And we'll say source subscribe. And for every value we get, we're going to do something. We want to pass our completions through. Not yet. We'll get to that in a second. And our errors we definitely want to pass through to the subscriber. The errors we want to say, well, this is, we had a problem. Let's just terminate the whole thing. And that's what this will do. All right. So whenever we want to call this projection function. So let's do this naive way first. Make our inner, say project value. So this is going to be an observable. And right here, we're going to say inner subscribe. And when we get a value from that, this is our inner value. We want to next that out. If we get an error here, that, we should probably terminate everything. So we're just going to do the same thing as what we did here. It's fine. And then if we complete, this is different also, right? So the reason that I have these question marks here is you don't really want the out, as soon as, let's just say you have an outer observable that's just synchronous, like here's 5 observables, and then you wanted to flatten those and subscribe to them. If you kill the whole result when that outer observable ends here, then you're not going to get any of those values, right? So you want to wait until the inner observables are complete as well. But if all the inner observables are complete and the outer is not complete, you might get more, right? So there's this balancing act that you have to do. So we need to track whether or not the outer is complete and how many active inner subscriptions we have. So we're going to do that like this. We'll say active 0 and let is complete. This is just our outer completion, be false. And what we'll do is inside of here, we'll say active plus plus, we'll increment it. If it's complete, we say active minus minus. We'll say if active is 0 and is complete, then we can complete our subscriber, right? And then this here's kind of the same thing, but we'll say is complete equals 0 or is equals true. And if active 0, then we complete right here, right? So same basic idea. Now, this is, that's taken care of. This, we've got this inner subscription here, right? So we've got this, we've got to come down here and be like, all right, let's do something here. We can return the subscription. That's fine. This gets a little wonky because we need to add this, and I don't really recommend doing this. It will work, but it's not really the subscription that should own this, because what's going to happen is if you make this subscription own the inners, then when it completes, it'll actually unsubscribe from these things. So you don't want to do that. That's a no-no. You can either say, I want to create a subscription like this, new subscription, and then add everything to that subscription. So this is one plausible way to do this. And then here we do the same thing. It's already adding, and then we return it. So that's one thing you can do. I didn't import it. And that will work to manage our subscriptions. Or a lot of people don't realize this, but a subscriber is the marriage of a subscription and our observation. So this subscriber is our downstream, it's our consumer, it's our the thing that's subscribing to this data. So it controls our subscription. So I don't really need this. I can actually add those things this way, and it works. And I don't need to return subscriber either. Believe it or not, this exact subscriber instance, when you subscribe to an observable, like the next bit subscribes, the subscription it returns is the same subscriber instance. It's just we use TypeScript to hide all the next errors and completes. It's a leaky abstraction, but it's done for performance reasons. So we don't even need this technically. If you add stuff to this subscriber, it will be added to the teardown. In fact, if you return a function here, if I was to go in here and be like, oh, okay, return, hi or something like that, this, as soon as it's returned, we'll just do subscriber.add like that. It's literally these two things are the same. So just a tip, something to know. All right, so we did all this. Our merge operator, our merge map is looking pretty good. So if I go in here and I say pipe my merge map, and I take the value, which is a number, and just for now, I'll say of and do I not have of here anymore? I do. Okay. So you can see I'm flattening this out. This is making an observable of like 0, 1, 2, 3 is what's coming in our interval. And then inside of here, I'm just tripling it, right? Pretty cool. Not so bad. Now, here's something crazy about this. So we've got this all working. This is a synchronous thing. I mean, I could put like an interval or something inside there if I wanted, map stuff out. Like you can do all sorts of crazy stuff inside your merge map. We're flattening now. That's awesome. But let's just say that I create a new type of observable, or I could even use like range or something like that. But just to illustrate the point, let's just say I've got this observable. It's we'll call it Firehose. Firehose observable, all it does is create numbers for us. And how it creates numbers is literally going to be in a while subscriber dot close. So if it's not closed, rather, as long as it's not closed, let's subscriber next and then some number out. Let's 0. And just for safety's sake, because I don't want to have to reload this stack blitz over and over again, I'm going to say if n is 100, then let's just subscriber new error to many values. All right, so this is basically saying like I'm going to pump out 100 values synchronously as fast as I can. And the reason I call this a fire hose is because this is going to be synchronous. That means when I subscribe to this, so I'm just going to unsubscribe to this other one real quick. Where am I? Right here. That means if I subscribe to Firehose, you know, I get this. It's just going to go until it gets 100, and then it's going to error, right? And like I had this expectation too. Like let's say I don't log here. Let's say I log inside the Firehose. Let's see. Right. So it's showing what I'm doing there. If I do this and I say pipe take 3, you know, I should only ever see these 3 come out. So that's good. So this is what we want to see. Now, with our primitive merge map here, let's see what happens if I return Firehose. And then wait. So we got all the way there. Where did I jump to? If I return Firehose, and then right after that, I say, wait, I only want to take 4 values. So if I scroll up, you can see I took 4 values, but check it out. Like it kept going, right? Like this inner observable never ever was closed. Never. But everything we did here is correct. Like everything we did here is how the RxJS documentation would describe and say, here's how you should do this, right? So why is that? The reason is that here's where our Firehose is being subscribed to. In order to close this subscriber, we need to unsubscribe from its subscription. And when do we get a handle to this subscription? When subscription is done and it completes, right? So if I didn't have this bit in there, the very first one of these inner observables we got, it would just lock up. It would just stay locked. It would never, ever process anything else because the thread would be eaten up by that while loop forever. And there's no way around it. So this is the synchronous Firehose problem. And this is what comes across, what happens when you get into more advanced things like I want to develop my own flattening operator. And it's only really a problem with flattening operators, realistically. So let's take a look. What do I need to do to solve this? In RxJS, we solve this a variety of ways. And the main thing that you end up needing to do really is you have to create your own subscriber. And as I stated before, subscribers are both the observer and the subscription. So what's going to happen here is instead of passing in this observer, which then gets wrapped in a subscriber, or this observer, which then gets wrapped in a subscriber, what I need to do is I need to create a subscriber. And when you create a subscriber, what ends up happening is there's some code. Actually, I'll just jump right to RxJS and show you. Let me move this palette out of the way. There we go. So RxJS, here. So if I go in here and I find subscriber. All right, let me make this bigger. So if I'm in here, you can see there's some code that says, here's a destination that I'm passing in, and it can be an observer, a partial observer, or whatever. This is how we take your function. If you just pass a function to subscribe, or a partial observer to subscribe, we take it and wrap it in a subscriber. Or if it's a subscriber, because we're dealing with an operator chain. And what it does is it makes sure it's a full-fledged observer. And if it happens to be a subscriber, it will also have an add and unsubscribe method on it. And these turned off. It'll also have an add and unsubscribe method on it. And that means it's a subscription. So really, this is just testing to see if it's a subscription, and we're going to add it. So destination is the downstream. That's the thing you want to control you. This is the consumer. You want that to control the subscription, and we're going to add ourselves to it in the subscriber. So we have to leverage this bit here. And what we're going to do is we're going to say right here, we got subscriber. And let me, well, there's a couple ways I could do this, but I believe we're just go new. Call this the outer subscriber, new subscriber. And the destination is going to be this subscriber. And we don't really have, like, there's not like a super amazing way to add these things in here, right? So this is, all right. What I'm about to show you is stuff you're not supposed to be doing with the RxJS, because we weren't exposing this to other people. We were just telling people to develop things this way, and it doesn't really work. No matter what you do, like, you need to be able to pass the subscription in, like bind the subscriptions to each other here before this goes in. So like what we're going to do is we're going to say, we'll take this and we can do this and say, here's our outer subscriber, and take our subscriber and add our outer subscriber to it. All right, see how this is deprecated? We didn't want people using this. No, I mean, you shouldn't, but I'm going to show you the better way to do this afterwards. That's coming in RxJS 8. It's deprecated, it's not removed. But so if you add the outer subscriber there, and then you subscribe with it, crazy as this is, it should work. And I'm going to show you the better way to do it afterwards. So let's go. Let's try this out. I don't know if I've actually done it this way before, believe it or not. Let's see. So take our outer subscriber. So we chained these two. So this here is inherently tied to this subscription. And this, when you subscribe, it will be like, oh, this is a subscriber. Like, it's also my subscription at this point. And this is just a superfluous, yeah. So there's that. And we also need to get this one here. So we need to go in here and say, inner subscriber, new subscriber. We'll just take this stuff and pass it in. And then we're going to add this to subscriber.add inner subscriber. All right, here you go. We solved the problem. So this is, I mean, this is super nutty, but like just to describe what's happening here, if you pass a subscriber instance to a subscribe, that is your subscription. It controls it. It's effectively a cancellation token at that point, because it's both the subscription and the observer. So you've kind of married them together and said, here, subscription, use this. And internally in our subscribe, we can look at this and see, hold on. We look at observable. internal observable. We look here and we look at our subscribe call, which is way back down here. You can see if it's an instance of subscriber, just use that, right? And then it returns it. It's the same thing, right? So it's this weird scenario where we're taking this, and I know this says deprecated. Honestly, maybe we should undeprecate it, but in this upcoming version, in version 8, there's a better utility for this. And it's better for a few reasons. But okay, so I'm gonna, just so I can get to why it's better for a few reasons. So we got this working. We're using our deprecated subscriber. I'm gonna tell you that if you run into this issue, it's okay. Generally speaking, you do not have this issue unless you're dealing with completely synchronous observables. And honestly, if you have a completely synchronous observable that's outputting hundreds or thousands of values, what are you doing? Like, you probably should not be doing that anyways. It's not really what RxJS is for. RxJS is for coordinating events and that sort of thing. Generally speaking, in my opinion, if you've got streaming data and you're dealing with large synchronous sets of things, you should be streaming arrays of stuff, not taking the array and then merge mapping it into a bunch of individual signals, because that's going to be computationally expensive, right? Like, in some cases it can help you because it ends up working kind of like a transducer or something like that. But in the majority of cases, you're just causing a lot more CPU load and a lot more complexity usually for a little benefit. But all right, so we solved our synchronous firehose problem. Just to get back to this, we've got a couple weird bugs here. Like right here, I've got this project function where, like, if I was in here and I threw an error, throw new error, lol, right? It didn't come out of our error handler. Like, it's not gonna, let's see, just to make sure, error. So let's do that and we'll see. So we did get, we saw the error. So that's throwing inside there. But why? Let's see. Oh, because it's being wrapped by the subscriber. Okay. That's really not how you're supposed to handle that technically. What you're supposed to do in every case, so that's actually surprising. It shouldn't be doing that. But what you're supposed to be doing here is you're supposed to be saying, okay, so inside of this, or actually, let me think about this. Because it's synchronous, it's actually being caught by this here. That's why. So inside the observable, the subscription, when the subscription is being initiated, if there's any errors throwing during that time period, it will go down the error channel. So we caught it there. Let's take this. So our source interval, blah, 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 and then.
Can I ask?
Yeah.
Can I ask one question? Is it a good idea to subscribe to inner observable on line 59 inside of observable? Because if observable has no any subscribers, it will not be fired in the pipeline. I don't know how to say, but
yeah,
it will not be executed. The code inside of the observable if it has no any subscribers. But here we are subscribing to this and force is this code to be executed even if the consumer will not be subscribed to our function.
Yes. All right. So yeah, I understand. So that's one of the reasons that we're coming up with a better way to do this in version 8, because this is super confusing. But what's happening to this is here we've got this new subscriber, this outer subscriber. Bear with me. And you're using that to subscribe, right? And because it's a subscriber, it owns the subscription because we added it here. So this is adding it to our subscription. So it's chained and safe. And we've got this outer subscriber. And then inside here, we create this inner subscriber that we're also adding to our subscription to make sure it gets cleaned up if there's anything else. And like right here, we subscribe to it with this inner subscriber. So This bit here in both cases is what's making sure our subscriptions are still chained together. So we're not like leaking anything or whatever. Does that make sense?
Yes.
Right.
Okay.
So trust me, I don't like what this looks like either, which is why we're coming up with a better way to do it. All right. So generally speaking, what you need to do with this sort of thing when you write code is you have to say, all right, try, and then you have like let inner observable out. Right here, you'd say catch error. We'd say subscriber error if there's an error, and then return. So generally speaking, if you have a user provided function, you want to wrap it in something like this. And RxJS, as of like version 6, had, I don't even know how many try catches all over our library. And this is what you would need to do, generally speaking, to make sure things were safe, other than like in like weird corner cases, to make sure that the errors were passed down appropriately. So this is boilerplate and annoying. The other thing that's boilerplate and annoying is the fact that we have to pass through our errors in every single case. If we were to write our own map operator, you would have to pass through complete and error manually, and so on and so forth. You really only need to do this new subscriber trick in flattening operators, interestingly, but yeah, it's the same sort of issues all over the place. So we needed a better way to do that. Now, if I was going to write this the same way as we wrote things in say like RxJS 7, there's different things you'd end up pulling in. It would be like import, there's a thing called operate from RxJS internal, is it source internal or just internal util lift or something like that? And then there's another one, import create operator function, or no, is it create operator subscriber from RxJS internal operator subscriber? Yeah, all right. So we actually pull in these two things. And if we go, I'm going to go back here really quick and we'll look at that branch. So if we could look at the 7x branches, what everyone's using in prod right now, we can go and we can just look at like, I don't know. Let's look at map, let's say, just really easy one. If we look at map, we can see we can pulling in this operate, which is lift. Never mind this name, because I'm going to show you something else named operate that's way better. And we've got this here, and we got like this is wildly alien to everyone else. This create operator subscriber and whatever. This create operator subscriber is actually doing some work to make sure things have try catch around them, and also doing some work to make sure the subscribers are chained together. So this is stuff I'm currently working on for version 8 to kind of solve this problem. And what it looks like, and I've actually got a PR up that I was working on just last night, adding operate. So this is a thing you can see I've changed a whole bunch of files in here, but this is a thing where we're adding a new way to create operators. And this is how, like, going forward, you would create operators. It's the first time I've shown anybody this other than in the RFC. But if we look at this, let's find one that's particularly compelling. Like we'll do take last. That's a decent one. So take last. And see, view the file so it's not all jumped up with all the highlighting. Take last, what it does is you can say, hey, I want to operate and I'm going to send everything onto this destination. And then you kind of override next, and you can override complete, and you can also provide a finalize. So like this is the sort of thing. So instead of saying I'm going to create a new subscriber with this like new subscriber and then pass in next error and complete, like it's the exact same thing where this is your next, this is your complete. We also have a finalize. So this is exactly the same thing you'd normally pass in. It's just you give it a destination. And what that's going to do is it's going to say, hey, if you don't provide an error, I'm going to forward everything along to this destination. Also, the destination is what controls your subscription. So as long as you provide this, your subscriptions will always be wired up properly. It will always, like any error that's thrown inside here or here will automatically go to the destination. You don't have to do anything with it. And I don't need to go in here and type like, you know, error is like this, the bit that where I would say error and then forward the error onto the subscriber or to the destination is what I call it in this case. You don't have to do that anymore. That's all automatically done for you. And that means if you write a map operator like this is all you have to write for a map operator, as opposed to subscribe and then you have a next, an error, and a complete, and you have to make sure that you're handling errors for the projection function and all that. Like all of that boilerplate goes away, and we just have this. And if you were to write your own operator function, so this is version 8. If you're going to write your own map operator, you would literally write it with exactly the same code that you see in our code base, as opposed to what you saw previous in our code base, where there was this create operator subscriber and a bunch of unnamed arguments, and then this other operate function that didn't make sense why it was even called operate to begin with, and other stuff that was internal and you wouldn't actually use. So RxJS 8, we're moving towards making sure that everything's developed the same way that you all would develop things, so you can use it as a reference point for how you might want to develop things. It's also heavily commented as to why certain things work the way they do. Actually, like a good chunk of this code is just comments, really. So yeah, so this is the future, instead of this gnarly gobbledygook that I had to do here with this subscriber and all of that other stuff. And the reason that this stuff works is what actually I did, and I live streamed it actually yesterday, was I went through and I took all the logic from our operator subscriber and these other things that were internal to RxJS, and I added them directly to subscriber. And then I wrapped it in that operate function that you saw to make it a little bit more clean, so people weren't saying new subscriber all over the place and then having to know what the different arguments to new subscriber were and how they work. So anyhow, I think this is probably the biggest bulk of kind of what I wanted to show you about what is a synchronous firehose. When you're developing a map operation, why can synchronous firehoses bite you in the butt? And it's because of that. It's because of the design of observable, really. It's because observable has to return the subscription, which means by the time the subscription's been executed and synchronous firehose is running, like you don't have a way to cancel it yet. So yeah, any questions about all this stuff?
Hey, Ben, Adam Barrett here, longtime listener, first time caller. I just want, so the TC39 proposal, subscription doesn't have an ad. So does that mean that the proposal is fundamentally flawed because it's going to have this problem, but have no way to solve it?
Yes and no. I mean, the biggest problem with, there are some problems with the design, and they do have subscriber.close, so that's a thing. They like the ad thing isn't as big of a deal, because what you can do is you can create like a set of functions or something, and then in the bit that you're returning down here, be like, you know, return, and then you have your teardowns or whatever you built up, and just for each or whatever, like that's what you would end up doing. Something like that, right? So you'd have like some set of teardowns where you added all your subscriptions to it and then did that. But yeah, like one of the things that the committees are struggling with right now is like a decent cancellation mechanism. Like there's a abort signal, but abort signal is super cumbersome to deal with. There's no automatic chaining. And actually add and remove event listener is ridiculously slow. Like I tried to leverage it in a side project I was working on, and it was easily 10 to 20, 30 times slower than just like using a set of functions or something like that. So yeah, there's that's a missing piece. Like, honestly, I think that they need to introduce some sort of lazy, I wouldn't necessarily call it a signal, but some sort of lazy flag type that's like, has this flag been flipped? If it has, then when you register an event to it, fire it immediately. Otherwise, allow people to register events and then give it like a flip flag, because that's all a subscription is a subscription is like, it's like this semaphore, this flag that's like, hey, am I active or am I not? Or basically, am I closed or am I not? If I'm already closed and you try to add something to me, I just call it immediately. Otherwise, you add handlers to me. And then when somebody unsubscribes or flips my flag, I mark myself as closed and execute all this stuff and clean up, right? Like that's all. So a primitive type like that would be incredibly useful in JavaScript. It's just not really available. So yeah, like the proposal, it lacks that, but I'd still take it as is over the status quo of like not having anything and people keep reinventing broken versions of these things. The other thing that I would even be amenable to in the proposal would solve the synchronous firehose problem would be like, all right, observables are all forced asynchrony like promises, right? It would be somewhat sucky in some ways, but I think it also might make development easier for folks in other ways, and it also might make it more palatable to the committee. So I don't know. And then you don't have to worry about, you can return subscription and it doesn't matter because nothing is ever executed until after that return happens. So it would make the type slower. Like there's not, like, no matter how you cut it, like it's not going to speed things up to schedule every event. So, but maybe you just schedule the subscription. I don't know.
Thanks.
Yep. Nothing. No questions about this. So this all this work that I was just doing recently, where was it? Pull requests.
Can you make the font bigger?
Yeah, of course. So this is just like I mean, you can see all these different commits, and all these different commits are just me refactoring each function. So if you go and you just look at one, like, I don't know, end with, it's probably pretty boring. You can see that all it's doing is changing from, we already moved everything over to look like this, but instead of having this operator subscriber, create operator subscriber, we've got operate. The operate function might be worth looking at. Let's see. It is in subscriber. So I just added it to subscriber, and inevitably, like, I'm probably going to have subscription, subscriber, and these things live in the same file as observable, like just have them all in the same file because they can't really do anything without each other. And having them in separate files, regardless of how people feel about the purity of the files that they're organized in, really just it causes some extra like boilerplate when people go and they bundle stuff, because now you have these like require statements or whatever that are pulling in stuff from different files that don't really exist. But yeah, so down here at the bottom, right here, this is the operate function. You can see it passes the destination, and we pass in these subscriber overrides. And the subscriber overrides are pretty simple. What they are is you've got like a next, error complete, and a finalize, and we just register them. And this is all right. So this is where I'm getting a little bit cute. So let me bring up the raw file version. View file, yeah. So I'm getting a little cute here. Well, I'm putting these things on there, and the reason I'm putting them on there is because there's two ways to go about this. Either I can be like, hey, you provided me an override, and I can inline a function right here, which means every new instance of subscriber is going to create a new function instance. Or I can stuff things on my context, on my this context, and then leverage them inside of a single function instance that is then shared amongst everything else. So that's a little bit of an optimization. You wouldn't have to do it with an app, but you do have to do it with library code that's being executed, millions or thousands of times by code. So yeah, so you can see this is being, try the override, which we know we have in this case. And if there's a problem, then send it on to the destination. If you give that override an error function, it's going to put it in here. It's going to try it. If there's a problem, send the error to the destination, and then make sure that you call unsubscribe. Same thing for complete. So that's really kind of what's happening under the hood, other than if we go back and we look at this, we just make sure that we're getting the destination in. So that's all that operate function is doing. It's creating a subscriber for you, and it's saying, wire it up to this destination, and then give it these overrides that have the error handling and stuff in them for you. And if you didn't override error, that's great. Just like use the regular error handler, right? Like, so it's just kind of automatically wiring stuff up for you to make things easier, less boilerplate, make your code a lot smaller if you're building your own operators, and makes our code smaller. Although I will say that the size of our operators, because we're trying to do things the same way everyone else is, I am allowing them to get a little bit bigger, just a couple bytes bigger in every case. And because I'm trying not to code golf it as much, I really want to make sure people can come look at RxJS as the reference point for how they should be developing their operators, which up until now, it was not a thing. Like for any version since version 5, I would, if someone was like, oh, I'm just going to copy how RxJS is doing it, which I've seen people do. I was always like, yeah, you probably don't want to do that because you're relying on some internal optimization stuff that we're doing, or some internal patterns that we don't even like anymore. Like, so yeah, this is sort of the final answer when it comes to stuff. Oh, another interesting point about RxJS 8 is, and we can actually just go look at this probably, code, is where we actually got rid of lift. And there's a reason that we got rid of lift. There's several reasons we got rid of lift, actually. But to understand why we got rid of lift, so normally lift would be in here somewhere, and it's gone, right? Like it'd be like right there. If we go and we look at version 7, there's lift, right? So the reason that lift existed before is because we had, how do I put this? When we first developed RxJS, closures were really, really, really slow. And so this lift mechanism was nice, because what you could do is you could say, create an observable, tell it what my operator is, which would be then lazily evaluated whenever you subscribed. And the operator was responsible for creating a subscriber and like actually subscribing to whatever source you had. And so what this enabled us to do is kind of take subscribers and lift them up and connect them to each other in a way that didn't require closures. And then about 2 years after RxJS 5 was released, closures became so fast that this optimization went with this. Now, the other thing that lift did is we had this opportunity to override lift on custom types. So before pipeable operators, if people remember, I don't know how many people here were around using RxJS then, we had this idea of, you'd say RxJS add operator map, RxJS add operator filter, and it would literally decorate the prototype of observable, and you could do like observable.map, observable.filter, and so on. And you did dot chaining instead of this pipeable thing. And there's a few problems with that. One is that you're basically polluting a globally shared scope, right? Like prototypes on objects are global state, like shared global state. No matter how you cut it, no matter whose prototype it is. So that meant that a library could add map. You could start depending on map, having not added it yourself and not realize it. And then all of a sudden the library decides it doesn't need to use map, and it breaks you. And there's no way for like to reconcile that other than you to be like, oh, why isn't map here? I guess I'll just add it, right? Like, but it would just randomly break your build, maybe even in a patch update of some library. So that was a problem, and pipeable operators solved that problem. And it also solved a lot of other problems. It was easier to develop your own custom operators now because it's just functional programming. And that also meant that the other advantage of lift went away. So one of the other advantages of lift was that you could take types that inherited from observable, and then override lift to make sure that it returned the same thing. So people don't realize this, but because of lift in versions of RxJS 7 and under, you can cast, like you can say subject, map, filter, whatever, and then cast the result of that as a subject and call next and error and complete on it, and it will next into the top of that and all the way through. But the reason this existed is you could create your own custom observables, add your own methods to it, and then do map and filter and whatever, and still have those methods. Now, the problem is TypeScript doesn't support this at all, because that's like really, really, you'd need higher kinded types, and they don't do that in TypeScript. And then, the other thing about it is it's just a weird, like, so it doesn't make a lot of sense. So let's just say we go subject, and we used to have these operators that returned connectable observables. So you have a subject, and you're like, okay, map, filter, whatever, and that you still have a subject at the end of that. And then right after that, you do like publish or publish last or something. And now you have a connectable observable that has a connect method on it. Okay, so now all of a sudden you've lost that next method. So there's things about it that didn't make a lot of sense, but it's gone now in version 8. It's gone for a variety of reasons, that not the least of which is that our operators in version 8 will work with anybody's observable shape thing. Like, so if you've got, if you make your own homegrown observable, as long as the subscribe contract will take an observer and return an unsubscribable, it will just work with, say, our map operator or our merge map operator or whatever. Like, you don't have to do anything. You don't really even have to do from on it if you don't want. So there's things like that we're able to do if we don't have lift. Let's see, other stuff coming down the pipe, coming out, that's ironic, is that I've got a PR here to look at this. A new method of piping has been added. So this is approved. This is probably going to get merged today and published in RxJS Next. Got some confusion. That's fun. But basically what this looks like is, it doesn't look like this anymore. It's Rx, not just R. And it looks kind of like this, where, let's see, there's probably examples in this. Rx spec. So basically what it does, it takes the first argument and it converts it to an observable, right? And then the other thing it does, it allows you to chain operators. So it's basically, it's totally synonymous with you being like, from this, pipe into these. And there's a few reasons that we did this. One is that it's a really common thing. Someone will be inside of a merge map and have a promise and then want to use an operator and have to do from promise pipe into these operators. And that just, it gets a little verbose and silly. The other reason is that if you implement operators that expect a pipe method on your observable, all of a sudden, it doesn't work with anybody's observable anymore, right? Which is what I stated was one of the goals we had, which is like, wouldn't it be nice if we can make this work with anybody else's observable? So that's another thing that's coming in RxJS 8 is the ability. We're not going to remove the pipe method, by the way. Like, I don't even know if ever we'll remove it because so many people use it. But once this is released, I would recommend this using the Rx method or the Rx function instead to chain things. This is just our tests to make sure the types are proper. Other stuff that's interesting, actually, this demonstrates it here, is our pipe methods on observable and the piping that you do with Rx will work with any unary function from now on. So if you are like observable pipe and then you pass to it like something that takes the observable and I don't know, like two strings it or something like that, the very next function in your pipe will be a function that takes a string and you can return whatever you want, and then it'll take the return value of that and pass it to the next function in your pipe. So you could make a pipeable function that subscribed to the observable if you wanted. You could do anything you want. It's just functional programming. That's something you could do anyways, but our types actually support it now. So that's something else to be aware of. I don't know. Any questions about what's coming up in RxJS 8?
When's it coming out?
Let's see. Well, it's technically, there's already alpha versions out. If you use npm RxJS at next, you'll be able to get that. I'm going to be publishing another version of that here shortly. The major bit of work that needs to be done outside of this moving over to the operate function and merging this pipeable bit in is I need to get the entire repository moved over to like a monorepo like NX or something. And the reason we want to do that is we also want to publish observable by itself, like just the core pieces like observable subscriber subscription, those things by itself, totally standalone as a separate package. The regular Rx package will remain unchanged. It'll still have observable and everything in it. But we want to publish the observable on its own as a standalone thing as well, because there's library authors that want to use it, but they don't want to include all of the RxJS operators, because once you do that, you're like, yeah, here's an observable. And by the way, here's this Pandora's box of tools you can use in ways that maybe they don't approve of, right? I know for one that I might actually use this in some environments where I have a bunch of people around me like, I don't feel like correcting a bunch of RxJS code today. Like I'd rather just subscribe and get it over with. So yeah, so that's the other bit of work that needs to be done. I would say like I was really optimistic that I was going to be done with that by now, honestly, but like at this point, it's looking like it's probably a couple months out still. Yeah. Anything else?
I could ask.
Go ahead, Adam, go.
I was just going to say, I could ask a different question that isn't related to the stuff that's coming out.
Yeah, go for it.
Well, you mentioned that like event listener, trying to use like the built-in one is slow. And then on a tweet somewhere, you also mentioned that like generators, it's actually better to kind of roll your own iterable than using generator functions.
That's right.
Which is cool. But like, why do you think that is? And like, why don't we all just use our, a hand-rolled one or a library than like generator functions and event listener?
That's the reason. Why do I think it's faster, or why do you think?
Why do you think they're so slow? I guess. Because or is that just an optimizer, like that compiler should be optimizing that, but not enough people are using it or something?
Generators are how do I put this? Generators are a subset of iterators, right? Like, so generators are very specifically like iterators that also do coroutines, right? So not only can you say, give me the next value, but when you call next, you can pass a value to it and it will send that value into the generator to be used, right? So if I'm in, excuse me, I'm sorry. Let's see, if I'm in here and I have some generator function, and then let's kill this so it doesn't keep subscribing over and over again. So if I have this generator function and I'm like, console log yield I, right? If I do that and I say, let's create my generator function, generate, and then for so I yielded undefined, or I yielded high, and then I'm logging what's being passed in there. But like what people don't know is, okay, yeah, so this action passed in undefined here, that's what I'm actually logging. So let's see, from outside. See, like it's this weird. So hold on. So let's make this more interesting. Console log g next inbound value. So wait, so it got this, but it won't actually get to the next one. All right. Well, hold on. So this is why it's wacky. Let's see. X equals this. So there's that, and then we can do G next to force it to the next bit. Really? We didn't get anything? Wait, what do I have to pass in here? Does it need an iterator result? See, it's been a while. Man, how do I coroutines?
I think you were doing it right,
Yeah.
but you need to call next again, right?
Yeah, that's what I did right here.
Oh, yeah.
So yeah, it's maybe because yield, I don't know. I don't know, it's super weird. You think that it would just go, value. So we got high here. That's this one, and then this one, I don't know. Hold on, let's log what comes out of it. It should have sent something in. I don't know. I have to look this up. It's been a while because it's almost completely useless. But yeah, this is saying it's not done. We didn't get anything. That should have yielded something, right? Am I crazy?
I feel like it should have yielded the value in.
Yeah, it definitely. I swear, like maybe. Hold on. I have a distrust of what's happening here. Let me put this into a different tool. Hold on. Sorry. I put it over here. This is going to be really small. Sorry. I think I might be able to make it bigger. Sorry. If I put this here and I run it. I'm just dumb. I guess I don't understand how to do generators. Like, I could have sworn that, yeah. So like the whole thing with coroutines is generators allow coroutines, which allow you to next things in at the same time as you're yielding things out, right? And man, all right, that's it. We're going to MDN it now. See, this is what I do with my life. MDN generator coroutines. Iterators and generators. Yield. Do you yield? Yield index plus plus. But that's not a coroutine. Generator. So tell me about coroutines. Yeah, it's these things are just, they're not allowing coroutines. Maybe they took that away. I could have sworn that you could do coroutines inside. There's no way they took that away. That doesn't make any sense. I'm so confused. Is this real life? Tracy, we're off the rails. This is not RxJS anymore. This has just been wondering like why you can't do.
Are we blaming Adam?
And it's Adam's fault. Let's look at this random thing. Yeah, so right here, this is what you should be able to do.
Copy and paste it, copy and paste it.
Right?
I take full responsibility for this derailment.
So, and then what's it saying to do? Yeah, tester. All right, so we should be putting things in there. So hello, first got undefined. 1, 2. First I got 2. So all right, yeah. So you need to do 1 to prime it. So this is just to prime it. So the reason that I even know this is we tried to make RxJS out of these generator coroutines, believe it or not. Right? Like, so we were trying to be like, oh, well, you give me a generator instance instead of a subscriber, and I'm going to leverage that. But that meant subscription time, you had to call one of these to prime it. So it would actually get to the first spot to where then you could yield out the next time it next. That's when you get the value out of it, which is here. And then, so that was my problem before. I only had 2 yields. So this 2 goes in. So this first one gets us to run up to here. And then you say, give me the next one and pass 2 to it. Right. And it gives me 2, and then it executes the next bit, almost like a function. Right. So that's where I screwed up before. So if I went back and I can even go back to it. Let's see right here. So go back down here. So here, this one, it's just, I yield that high. This one, I wouldn't get this until I did this one here. This is just priming it. So yeah. This one here gets passed in to the next block after yield. So I wasn't crazy. I just was using it wrong. Just like the story of everything with code. But yeah, anyways, so long story short, why generators are slower than just an iterator. So just if I was going to implement an iterator, like, oh, I got this, I got a next on it. And then when you call it, I return something done, you know, false, value high. Like this is an infinite iterator of the word high, right? The reason that this is going to be faster should be really obviously apparent. There's nothing fancy going on in here. There's no like coroutine stuff. There's nothing for the runtime to figure out or execute as far as like the logic about what should come out of yield and whatever, where all of the other generators and async generators, they're going to have that additional logic that the runtime has to process. So that's why this is faster. It's just simpler more than anything else. But generators, again, are a subset of iterator. So it's like not all iterators are generators, but all generators are iterators. That makes sense.
Can I capitalize your time and ask another thing?
Yes.
Based on, if you have time, based on what you were showing us before, and for my own selfish needs, could you implement an operator, a flattening operator, that is like a fork join, except it's like synchronously gives you back an object and just like gives undefined for anything that hasn't emitted yet until it does emit, and then, if that makes sense.
All right. So say
And
this
then
again.
send the stack puts so Adam can copy paste it.
That might be true.
say this again. So it's what are the requirements?
It's like a fork join where you can like take a bunch of observables and it returns an object, a dictionary or an object where
Okay.
each property is mapped to these things. And
Yeah.
but fork join waits until they've all emitted once. I would like something synchronously back that just has undefined for anything that hasn't emitted yet, and then have the emitted values come in as they
So basically you give it a bunch of observables, and if any of them emit synchronously, it's like, hey, here's, you know, here's those values, here everything else is undefined.
Yeah. And maybe there's a way, maybe you don't have to make your own.
And then you
operator.
want
Maybe
every
there's already
value after that, right?
Yeah.
Okay, so that would just be, let's see. What are we going to call it? We'll call it Adam's things. And I'm just going to say args because I'm too lazy to figure it out. And then
Well, the args could be an object with keys that are all whose values are all observables, right?
Sure. Well, we'll figure out the types later. Let's see. And then here it's going to be combine latest. And that combine latest. So in this case, if it's an object, if we want like a dictionary, that's one thing. Let's just do like array of observables for now, just for whatever. If that's the case, you could take this and say array observables and map it to be like, here's the observable. And we want to do observable. This is like the super cheap way to do it. Pipe, start with undefined. Right? Like this is the super duper cheap way to get exactly what you want without having to build anything custom. But like, it's going to emit twice right in the beginning if any of these are synchronous. But what's going to happen is you've got this combine latest. Every single one of those observables that's inside the combine latest is going to emit undefined immediately. And then maybe also other synchronous values, right? Which any of them could have done regardless. It's just adding an additional undefined. And then after that, every single value comes in and you'll get them, right? So, but this is in an array format.
Could you fix the undefined problem where they don't emit the first time undefined if they have a synchronous value available?
Maybe, but why?
Because that's what I want.
You're like my children. All right. So yes, but then you're going to be building your own operator from scratch that is combine latest. So, I mean, yes, the answer to that is yes, we could absolutely do that. This is the easy mode. So this is easy mode, right? And then Adam's saying hard mode. We're going to have to take an argument that, again, I'm just going to do an array of observables for now because it's easier to deal with, but you can alter it to be a dictionary if you so choose. Or fine, I'll do sources, record, observable, input, any. You figure out the types on your own. That's a pain in the butt. And we return a new observable. Again, going to put any in there and we can figure out that type later. Then right in here, we're going to have to go through all of these and subscribe to them. So let's see, for const key value of object entries, sources. So great that it doesn't know about that in this version of TypeScript or whatever I'm using, but it should still work. And then what are we going to have? We're going to have our values, which is just a record, whatever. Let's do this because I'm lazy. And so for every one of these, this is a source. This is not a value. This is source. I'm going to say, and we're going to subscribe to it. For every value we get from that, we need to set values key equal to value. And what? I guess also we're going to have to do, this is going to be object keys. And what do we call it? Sources, map key. So this is just creating our first object. Our initial objects. This is going to make sure that we have all the same keys. We have undefined on it there. Here's where we're setting it. Every time it next after we set it, we want to grab or next. You can just next out all the values. You might want to clone that. I don't know. So people don't mutate it or whatever, but there's that. Make sure they import this. We want to pass through our air. And completes going to be different. So if any one of these completes, do you want it to complete or do you want to wait for them all to be done?
I would want to wait for them all to be done, but I don't want to waste your time.
So that means for every one of these, we got active.
Already sniped, Adam. Already sniped.
Active minus minus, and then we're going to say if active equals 0, then subscriber completes. Now we nexted out all those values here. So here's where we're all subscribed. And as soon as this for loop is done, we can just say subscriber next values. And what that's going to do is it's going to say, all right, so subscribe to every single one of these things. And we'll first set up this object with all undefines for every one of the keys. Subscribe to this. And if any one of these synchronously update that, it will be synchronously updated here, although I guess it's going to next out. So we could do this. Let subscribing equal true. If not subscribing. So we only want to next those out if we're not in the subscription phase. And then after, as soon as we get done with this, then we next it out, right? So, all right, there you go, Adam. That's what you wanted, pretty sure.
Brilliant. I'm going to put a PR for Adam's thing hard mode on RxJS to be a official operator.
It's not getting added. make your own npm package and publish it. Add your tests, maintain it.
But like, how
I've already
many
got 80
downloads does he
operators to maintain.
need? How many downloads does he need for you to like add it to core?
Add it to core. I don't know. You get up over 1 million a week and we'll talk.
Okay. Goals for you, Adam. Goals.
Scheduling our coffee for October.
So I don't know. Let's see. There's like RxJS 408. We just kind of rolled this functionality in. Let's see. npm.
We are
We're out of time.
almost out of time. Yeah, but we can end on this.
So this one here, I mean, it was up over 1 million for a while. It's gone down a bit. But yeah, this one here, we rolled in some of this functionality, not all of it, but in RxJS 8, you can subscribe to observables with a 408 loop. So you'd be able to just go like, oh, there's my observable, and just do an async function. In RxJS 8, you can say 408 value of some source. And this will totally just work. And it'll subscribe. And if you want to unsubscribe, break the loop. So that'll work. Now, the thing you have to be aware of is everything that happens inside here is basically going to happen like a concatMap. Like it's going to buffer every one of these values until this loop comes all the way around. So if you've got like an await, sleep, 10 seconds in there or something like that, it's not going to pull this next value out until this whole loop executes and comes back around to the top. So it's not the same as just calling subscribe, but it's a tool, it's available, and you can unsubscribe with it, and it's interesting. So that exists in RxJS 8 as well.
And every iteration would be scheduled too, right? Every time it goes through around that for loop.
Technically, yeah, that's right.
Cool. Well, thank you, Ben. Thank you for sharing all your knowledge with us and hanging out today.
Yep.
And we all had fun. You can follow Ben on Twitter at Ben Lesh, or find him hanging out in the RxJS repo. So
yep. And I have started to try to, every single time I do like large amounts of open source work, I'm trying to Twitch stream it now. Just so I can share, and also so people can help me catch mistakes. And also because I have a hard time getting people to review my code. And now there's videos of me actually making the code, which should make it easier to review the code. So trying for multiple win there. So
nice. Awesome. All right. See you all next time.